Hi, this is Mr. Manley. In this video, I'm going to graph a cosecant function. And we'll start off the way we start off all of these functions, all of these trigonometric functions. We are going to set up an XY table, or in theta, as the case may be. And we're going to set ourselves up with 5 points. And we're going to go for an initial point. Like so. So the initial point is going to be like all initial points except tangent and cotangent. We're going to set up the argument equal to 0. So actually all of the functions except tangent we set equal to 0 to get our initial point, and then solve for theta. So let's see what we have here. We have negative 5 pi over 6, and then times 1/2, right? When I divide by 2, that's like multiplying by 1/2. So that's going to give us negative 5 over 12 for our initial point. Negative 5 pi over 12. And that'll give us our initial point. There. And then we need our step, right? And the step is equal to the period over 4. And on these, the period is always 2 pi over the leading coefficient of the argument. So that's this, 2, is the leading coefficient of the argument. So that gives us the period. What does that mean? Do you know what that means? It means that every pi units, we get a cycle of the graph. And then the graph keeps repeating the same cycle. For instance, with sine, it goes, there's a cycle. And then there's another cycle. And then there's another cycle. Now, this one you might not be as familiar with, the cosecant. But with cosecant, it'll go like this. It'll go, there's a cycle, there's another cycle, there's another cycle. And that keeps repeating itself every pi units. So that's the period, and the step is the period divided by 4. So our step here is pi over 4. And let's look at that. If we look at that and compare that to this, I've got negative 5 pi over 12. So I want to have the same denominator. It'll be easier to add, right? And follow through on our step. So I'll multiply this by 3 over 3, and I get 3 pi over 12. So I'll use 3 pi over 12 as my step. And all right, so 3 pi over 12 we're adding. So negative 5 plus 3 is negative 2 pi over 12. And then add 3 is going to get us pi over 12. Add 3, and that's going to be 4 pi over 12. And add 3 and get 7 pi over 12. And then we want to take each of those and substitute for theta and evaluate. So y of negative 5 pi over 12, got 3 cosecant, negative 5 pi over 12 times 2, so that's negative 10 pi over 12 plus 5 pi over 6. Well, look at that. That's 10 over 12 is 5 over 6, right? If we simplify that. So I've got negative 5 pi over 6 plus 5 pi over 6, and that's a 0, right? So I go 3 cosecant of 0 plus 1. All right, well, what's that? Let's look at the unit circle. And at 0, I've got 0.10. And cosecant of an angle is equal to r over y. And in this case, since it's a unit circle, r is 1, right? R equals 1 on a unit circle. So that's going to be 1 over 0. Y, the y is 0. What's 1 over 0? Yes, that's undefined. So we're going to go undefined here. And hopefully you know by now that when undefined shows up in a table like that, graphically that's going to mean a vertical asymptote. So there'll be a vertical asymptote at negative 5 pi over 12. Okay, let's go to the next point. Negative 2 pi over 12. And we'll plug in our negative 2 pi over 12. So can we do that? Can we just think, all right, if I plug that in here, I'm going to have 2 times negative 2 pi over 12. All right, so it's going to be 2 negative pi over 3. But let's do the 6. All right, so yeah, so 2 times negative 2 pi over 12, and that's what is going to go in right there. Okay, so I'm evaluating this, and that's going in there. And I notice that I'm going to be adding it to 5 pi over 6. So let's simplify. We can simplify that like this. So we can go 2 with a 2 there, and then 6, and then keep the 6, right? Because then we'll have a why didn't I keep the 6? Keep the 6. And then we'll have negative 2 pi over 6 plus 5 pi over 6. And now we have the common denominator, right? So just keeping an eye out, being flexible with the numbers to make our calculations more convenient. So that's 3 cosecant. And then what's negative 2 plus 5 is 3. So that'll be 3 pi over 6, which is pi over 2, right? So cosecant of pi over 2 plus 1. All right, let's evaluate that. I go to the unit circle to pi over 2, and that's at coordinates 0, 1. And r is 1 over y is 1. So that means that this is 1. So the cosecant of pi over 2 is equal to 1. All right? Hopefully everybody can see that. If I do the cosecant of pi over 2 and cosecant of theta is r over y, so r is 1 on a unit circle, always 1, and then the y is 1. So that's 1 over 1, which is 1. Okay, so cosecant of pi over 2 is 1, and then we can just evaluate that, right? That's 3 times 1 plus 1 is 4. So we got our second point there. All right, let's do our next one, and that's going to be y of pi over 12 equal to 3 cosecant 2 times pi over 12. I guess I could do that, right? That's pi over 6. So I'm just going to call that pi over 6 plus 5 pi over 6 plus 1, 3 cosecant 6 pi over 6. That's pi plus 1. And this will be the last one that I show you because you can do these on your own. But here it's negative 1, 0. And so the cosecant of pi is r of 1 over a y of 0. That's undefined again. So I'm going to go undefined. All right. And then I'll leave the other two for you to work out if you need them to, but I'll just add them into the table. All right, so there's our completed table. We got a negative 2 in there and another undefined. So let's graph it now. See what that looks like when we graph these points. We're starting negative. Sorry, so I want a little bit of space on the negative side. And we need a little bit more space on the upside above the x-axis. Okay, so that looks good. What about our scale? Well, this kind of a couple of things that I'm looking at, or one, I'm looking at these denominators and going, all right, so the 12th is important. They're 3 pi, but they're 3 pi over 12 apart, so it's pi over 4 apart. So I mean, like my initial instinct might be, well, what about pi over 12? Right? And then when I count those off, that's 1, 2, 3, 4, 5. So I'd be over here for my starting position, and then 7, 1, 2, 3, 4, 5, 6, 7. I'd be over here. And so if you look at how far that is, now I'm going to have to do that again to get a second cycle, and I'm barely going to have space. I don't know if I'm going to have space to do it. That's so I got 5, 12, and then 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I don't have enough over here to get in a second cycle. So, I mean, fair enough. I could probably do it and maybe still read it. And it's not ideal, but students don't always do what's ideal, right? So let me show you what this would look like if it is less than ideal circumstance. So I'm going to stick with the pi over 12, and then that means that, of course, this over here is negative 5 pi over 12. I just counted off 5 to the left, and that's undefined. And as I said earlier, that's a vertical asymptote. Okay. Then I go negative 2 pi over 12, negative 2/12 pi. So that's 2 grid marks to the left, and then up 4. I'll just do a y scale of 1 like that. 1, 2, 3, 4. And then undefined at pi over 12 here. And then we've got negative 2 at 4. So it's 1, 2, 3, 4 is there, and negative 2. And undefined at 7 again, and that's here. This is 7 pi over 12 here. I don't need to label all these, but it's nice and convenient. All right, so what's the shape here? I showed you earlier, right? I said it's looking like this. So do we have, you see, that we have enough information to do that, right? So I'm going to go and take this point here, the first point, and I'm going to go up towards the asymptotes like that. And I'm going to take this point here, and we go towards the asymptotes like that. All right, now let's see what we can do about getting another cycle. And so to get to I'm going 1, 2, 3 to get to my next point, and then 1, 2, 3. You understand that? So 1, 2, 3, 1, 2, 3. That's how many grid marks I'm going. 1, 2, 3. So that 3 is going to take me to the next point in my cycle, which is the 4. So I'll put that there. And then I'm going to go 1, 2, 3. And the next point in my cycle is this asymptote. Then I'm going to go 1, 2, 3. And the next point in my cycle is the negative 4. And then, look at that. I ran out of space. So, yeah, less than ideal, like I said. But, I mean, there's the convenience of the pi over 12, right? I really liked using that. But I didn't get 2 cycles in. Am I going to lose points? Yeah, I need to know where that last asymptote's at. So, probably going to lose a point on that for not showing that. Maybe, though, if I don't want to redo the whole thing, but I want to show that I know where it's at, I could say my asymptotes are at, so I've got my asymptotes here at negative 5, and then where's the next one? It's 6 pi over 12 away, or pi over 2, but it's easier to add 6 and go negative 5 plus 6 is pi, and then plus 6 is 7, and then plus 6 is 13, right? So this is at 13 pi over 12. So maybe we can get that point back, and I can point over here and say there's another asymptote at and then just add 6 to the 13 at 19 pi over 12. You know, maybe the teacher would accept that because everything else looks really nice. Okay, so that is graphing a cosecant function. The secant works very similarly, but let me show you that when we're doing a secant function, all right, well, let's compare them, okay? When we're doing a cosecant, what are the points that I'm getting? I'm getting asymptote, point, asymptote, point, asymptote. And then I'm going up and up and up and up, all right? Cosecant, so that's cosecant. Cosecant, and then secant is, it's a little bit awkward, because what happens with secant is I get a point and an asymptote. Let's go like that, and then let's go 1, 2, and I get another point, and let's say that point's like here, and then go 1, 2, I get another asymptote, and then I go 1, 2, and I get another point. All right. So this looks a little awkward, all right? Because here's how I'm going to do this. Now I'm going to go like this. So it starts and ends on those points, right? Now these of course these do go like that, and this goes like that. Oh, so look, I'm already going toward doing another period, okay? So I could go like that. And then I can just go up 2 and just go like this and say, oh, I've got my 2 periods of secant. So you just notice how that was a little bit awkward, the way it's laid out, but then we just add on to it and get 2 cycles. Okay, so that's cosecant, and then secant. You get the idea of that as well.